Hi, this is Jason Ward, and this short video is just really a demonstration of my remote bird feed monitor, which we've built. There's far more detail in the actual report submitted, so this is just an overview of some of the key features, but hopefully I'll show you how I got to where we got to. So, further ado, let's go on. So the first thing is just give you an overview of the project. The idea is we're going to have a bird feeder and an IoT device connected to it, in fact built around an ESP32. The purpose of it is to take readings for temperature, light and humidity, which it will do, and then also for any movement coming in or near the bird feeder, namely a bird or, in practice, many other things, but the idea being there to detect motion or movement. What the board will then do is publish the data it collects to a broker, and then users can subscribe to the broker to receive the data and look at it and so forth. And then also users can publish commands to the broker. So we've got an element of commands in here, allowing us in the project, I've allowed it to stop the machine, stop the board, sorry, and or speed up the readings or slow down the readings, just as a demonstration. So the board itself then subscribes to the broker to receive these instructions, and the code within then changes what it's actually doing within there. Okay, so that's a broad overview. Oh yeah, I've also set up thin speak in Node Red for data coming back can be analyzed and so forth. So I've done a couple of basic interfaces within there, and hopefully I'll be able to demonstrate that in the video. So moving on. So this was our starting point. May look familiar, uh, which it's exactly where we got to at the end of lab 9 with the ESP32 board with the LM35 temperature sensor. I used this as a starting point, so I was going to need to measure temperature anyway, and it was I thought it was a good place to start from. So we went from there to this horrible spidery mess, which I will try and explain in the next few slides. So have a look at what's going on here. What we've got here is the LM35 has been taken off the board. So there's the LM35 sensor. We've got a photoresistor here, which is going to be used to measure light. And down here is a DHT11 high growth thermograph. What this measures is humidity and temperature, although in practice the temperature wasn't as accurate as the LM35. It seems to be off by about 5 degrees. So although we do record it and it's mentioned in the report, the main temperature sensor reading comes from the LM35. And then finally here we have our motion sensor, which is an HC SR501 PIR motion sensor. And this is used within the board to detect movement within the bird feeder itself. So that's how the board all comes together. And as you can see there, it's a very tidy mess of wires, which I will try and explain in the next couple of slides of how it all fits together. So there's our starting point, the LM35. So the first thing we did, we took the LM35 off the board because it needs to record readings outside of the boards, so to speak. I'll explain that in a second. You see the lines across the top, that is a 5-volt in for the LM35, but some of the components, so 5 volts across the top, but some of the components require a 3.3 volt, so we've rigged up the bottom lines to be 3.3 volts, and then, so we've got 2 voltages, 5 volts across the top, 3.3 across the bottom. So the next thing is the photoresistor. This required the 3.3 volt with a resistor, so that's very simple, and that goes to that pin there for the output. And then the DHT11. Now, this was originally, the supplier said it should be connected to 3.3 volt, which I've done here, but we found in practice that it just became intermittent and it would fail sometimes and shut the whole thing down. Looking that up, it was recommended to change it to 5 volt, which it did, and it worked fine then. For this diagram, I've left it on 3.3 volt to show that it's there. In the report, it's on the 5 volt, but we do mention that we went through this stage. And then that goes to that pin there. And then the final thing is the motion sensor, which comes in. That takes a 5 volt supply and goes to that pin there. So what we end up with is on pin 36, we're getting temperature readings. On pin 35, we're getting light readings. On pin 13, humidity readings. And on pin 14, movement readings. Okay, so that's the final board. So let's have a look at it in action. It's the little video here showing it all working. I'll try and explain what's going on as it goes through. So here's the code here. I have explained the code fully in the report, so I'm not going to explain it here. I'm just going to go through the key features. But what I've managed to do, I've managed to rig up a live camera to the device here. We can see it working. And then this is live MQTT Explorer feed. So you can see we've subscribed to all these topics here. Temperature, light, and so forth. So that's the first thing we do. And we've got a control channel and a messages channel. You may have seen that there. So what we do next is we're going to run the code. And the first thing we do, hopefully it gets to it, when we run the code, is we should see the blue light flash 5 times showing that the code is working on the device there. You can see that there. So that's telling me, that's my indicator that it is working. Now it's waiting to connect, and when it connects to the Wi-Fi, we should get a solid blue light for 5 seconds. There we go. Solid blue light for 5 seconds. So that's all working. That's telling me, right, it is connected to the Wi-Fi. And what's going to happen, it's now going to take readings, and the default value is every 5 seconds. So there, we've seen a reading come through there. And after 12 readings, it takes an average, and that's what it sends up to the broker. So we should be able to see that process going through. So every 5 seconds, we're getting a reading, temperature, light, humidity. If movement's detected, you will get a statement saying movement has been detected, and we're going to test that in a second. But if we look at the broker here, I think what I'm going to do is speed that up. So this is, as I say, I'm now going to put a 1 in here and publish that to the broker, and that should change the speed of these readings to 1 every second. So there, we can see there, readings will be taken every 1 second. We now see the readings are coming in thicker and faster, just for demonstration purposes. Right, so we've now had an average reading, and this is now being published up to the broker. So we should be able to get a little picture of that. You can see, yeah, we've got the first dot on the graph there. We should get another one any second because we're up to reading 11, reading 12. Yeah, so the second reading's there. So that all appears to be working. Now, put my hand there. You see movement's now being detected. And you'll notice the blue light came on as well as a visual indicator, the blue LED, showing that movement was detected. Yeah, so that seems to work fine. And I think we're going to test the LM35 next. See what happens. Yeah, so I'm going to hold the LM35 and we're going to watch what happens to temperature. It's around about 12, 13. It should start to rise. Yeah, it's going up 14, 14 and a half, 15, 16, 15, 15, 15. You can see movement's been detected as well, so the blue light comes on. So we're around 15 now, so we should see the graph change on MQTT any second. Yeah, so that's up to 15. I think I'm going to take my hand off. 15, 16. Okay, we've lost the visual. But yeah, we can see that the temperature has risen there, so that appears to be working. And when we get the next reading, hopefully it'll come down a little bit. Yeah, well, it's starting to level off. And then on the next reading, it will and should start to drop. Now I've taken my finger off. Just take a couple of seconds to get through to reading 12. Yeah, you're right. So we can see that dropping off now. Now the next thing is, this is Node Red, and I've just set up 4 simple flows here, one for temperature, one for light, one for humidity, one for movement. I think in the final version I've developed this a little bit more, but it is fairly simple. I've not done much more than that. And these are the readings that we're getting from Node Red on the dashboard. So we see, yeah, changes, so we can see that's all working. That's subscribing effectively to the broker and taking the readings from there. As I say, I think I have developed the dashboard a little bit more than what you see here in the final version. And the next thing we're going to look at is we've also set up ThingSpeak. So we can see, yeah, we've done various readings on ThingSpeak. Again, I've developed this slightly better by the time the final report went in. And that's essentially, hopefully you can see that's all working. In the next video, we're going to, on the next page, we're going to show it being detached from the actual system on its own power supply, just demonstrate that. So let's move on, and we should be able to see this. Right, so the first thing in this is we're going to take the code now, and we're going to, as you see, upload it to the actual board. So now the code is sitting on the board, and this is always the scary bit for me, because I'm now going to take away and I'm going to power it with this power bank here. So it'll not be connected to the PC. So here we go, and we should see the 5 flashing lights and the blue LED. Brilliant. So that's telling me the code's running. And then in a second, it should give a solid blue LED, which indicates it's connected to the Wi-Fi. There we go. So I'm now confident this is now running the code on there, running off its own power supply. Just to test. Okay, so there we can see movement has been detected. So that's good. And MQTT, let's see if it is publishing. So we'll just log in there. Take a second. Right, we'll change the speed to 1, just to speed it up a bit. So yeah, well it seemed to, well, it certainly published that. Let's see if we get some readings through. Just wait, it'll take 12 seconds. Right, so we've got a reading. So we're fairly confident this is now working fine, independently, on its own independent power supply. Okay, so let's move. Oh, what we're next going to do is place it in this box, which is makeshift. There's a hole in the top, which allows me to use a screwdriver to do the reset buttons. And there's holes in the side to let the sensors come out as well. And then that is going to be housed underneath this tent I've made out of cardboard and bubble wrap. And then I think here's a picture of the bird feeder that's going to be used. And it's effectively going to sit behind there. And on the next slide, you'll see that in position. Okay. So there we go. It's now in the box. We can see the sensors are coming out. That's hanging over into the bird feeder. Yeah, you should have seen the blue light there, motion detected. So that's now totally independent of the PC on its own power supply. That will sit over there. And the next thing we need to do is just place it in position outside, which we will do next. So here we go. There's my foot. Now this is at the front of my house, so it's difficult to get a good shot really. I need to put the camera out. You'll see I've got my hand hanging out the window. It's upstairs, it's quite a height. But you'll see there, the motion sensor's in there. All the other sensors are housed in the cardboard tube behind, and everything else is under the tent there. So that's that. So hopefully you've been able to see how I put the device together, how it all works, how it all fits together, and how it works independent of the, it doesn't have to be connected to the laptop. In the report, obviously, I go through in far more detail the readings we received and so forth. And I hope this short video has given you an overview of the project as a whole. Thank you very much.